the clip sounds interesting, isn't it? You might be thinking how we have created those customized charts. Well, to your surprise, all those charts are converted using R. So let's get started and see how can we represent our descriptive statistics results and insights from the data in the form of charts and customized graph using R. So we already have the loaded workspace. So soon we will be seeing our data that is stored in my_data variable. Now here we are going to add a new column called size just to label our data set. So how we are determining this column? Well, with the help of if-else condition. So the condition will be if the sepal length is less than the median of your entire sepal length, then the flower is considered as small, else it will be considered as big. So with the help of this command line, we are using if-else statement. So the condition, if the condition holds true, then the flower is considered as small. And if the condition holds false, then it will be assigned as big. So this is how we used a conditional statement in R. Now let's see our data frame. So yeah, we have created our column size successfully. Now let's analyze this column. So let's see how many big and small flowers are present in total. So in total there are 150 records. So let's see out of 150 how many big and small flowers. So yeah, we have 77 big flowers and 73 small flowers. Now we have only 3 species, as I have already explored this. So we have 3 species that are Setosa, versicolor and virginica. So soon we will be seeing how this big and small are distributed across each species. Basically, table is used to structure your data into row column format. So the first parameter distributes row and the second parameter shows column. So on row we have species and on column we have size. So you can see in Setosa there is only 1 big flower and 49 smaller flowers. Now let's see the reverse of it. For example, we'll be putting size on row and the species on column. So here we see the contingency table. Basically, a contingency table is used to show the relationship between qualitative variables. In our case, the qualitative variables are species and size. So here we get the exact relation, like how many big flowers or small flowers are there in which species. So basically a species versus size relationship. Now, it's important to also know the proportion, like what fraction of big or small flowers are present in which species. So here we get the proportion with the help of syntax prop.table. And we are rounding it off to 2 decimal places so as to get the clear picture. So yes, we get the clear picture. If you sum all the entirety of this table, it will definitely equals to 1. So basically, the most of the fraction of small flowers lies in Setosa, whereas the least number of big lies in Setosa. Now why we are doing comma 1? So as to get the row wise cumulative. For example, if you plus big flowers and small flowers or Setosa, it should be equals to 1. Now 2 to get the column wise cumulation. So if you add both the columns, both values should equals to 1. So this is how we get to the nooks and hooks of these 2 variables that are species and size. Now let's see how to draw mosaic plot. So a mosaic plot basically is used to show the distribution of your data. Basically, your categorical data or qualitative data. Here we are using column 5 and column 6. Why? Because 5 stands for species and my data 6 stands for size. So the first parameter will be equivalent to x-axis and and the next parameter will be equivalent to y-axis. So we are labeling the x-axis as species. Label. This is the parameter you should pass in mosaic plot function. Y-lab equals to size count. Now why we are using main? Main is to give the name to your graph. Since on x-axis we are plotting species and on y-axis we are plotting big or small, that is our size column. So let's see. So it is very basic graph, as you can see, big, small, gray represents big, small, and small represents lighter shades. So all these are very basic shade, but we need to color it, right? We can customize it also. So let's see how to customize our mosaic plot in R. You just have to do color equals to the color you like, and you can also give a border to it. For example, in this case I am using color equals to yellow and border equals to black. Don't you think it's very monotonous? Yes, because you cannot distinguish between big and small. The variations could not be seen clearly. So now let's see the variation in colors also. So here you just have to do shade equals to true and remove everything. For example, that is color parameter you don't need border. Instead of border you should use less equals to 1. Why we get this error? I'll let you know. Because shade equals to true is in double inverted quote, which is wrong. So just remove the double inverted quote. With the top arrow key you can get your previous command also. So shade equals to true and less equals to 1. So we get a very beautiful chart having different shade for each species, and you can also get the proportion value to it. So this is how we create a mosaic plot in R. So let's see how we can customize our charts with the help of library. So there is a specific library called R Color Brewer, and in our previous video we have already seen how to install a new library or package in R console. So here we will be using this library to select a palette, like we are selecting a palette of color, for example red, green, blue or black, white, gray. So there are different palettes. I'll be using set 2. So we are using the object called brewer and .pal represents palette. So let's see how to customize our bar plot. Very common among all the data scientist enthusiasts, because it is one of the graph that clearly shows the numeric value distribution of any column or any relation we can easily see from bar plot. Like basically the relation between two variables. So here we see the bar plot for the species wise big, small. Like here we see the what amount of big or small are present in which species. So here you cannot see the label, right? orange represents what or green represents what. So a label or a most precise term called legend is very important. So here we will be using legend equals to true. Now we are reversing it. First of all, I am just showing you the, so here you get the species, because we have on the parameter side we have reversed those things, correct? So this is how you create a bar plot for different combination of variables. Basically it is a stacked bar plot. So let's say legend equals to true. So here you can clearly see that small is represented with the help of color orange and big with the help of green. So I think I'm clear with how to draw bar plot. Now let's see the another very interesting graph, that is histogram. The most basic, the most fundamental, and I guess it is the most useful graph for any numerical value, because here we can clearly see what kind of majority lies in which range. So we have done the histogram for sepal length, column 1. My data, comma 1 represents column 1, that is sepal length. But since the graph which we have seen previously, it is very fundamental. Now let's color it. So I'm using green color. You can do whatever the color you want. So border equals to blue. So yeah, we are seeing the graph and it's quite attractive, isn't it? So let's label the x-axis, y-axis, and you should also give a name to your charts, because the person who is viewing your dashboard or say charts is unaware of what you are doing. So you have to clearly mention your name. So first of all, you should mention the label, that is X label. So we have used sepal length. So on X label, definitely sepal length should come, and Y label, the sepal length's value, distinct value, that is 5.1 centimeter, 4.9. So its value. Now main equals to name of your graph. Please bear with me with my spelling because I just mistyped it. I hope you like my video. So guys, please like, comment and share our video, and don't forget to subscribe. Thank you for watching.